All right, we're going to look at Part D of Free Response Question 4 right now. It says a second train, train B, is traveling north from origin station. At time t, the velocity of train B is given by that function, and at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. All right, so what we have is we have a train traveling east and west, all right, from a station. All right, and then we also have a train on a north and southbound track, and it says that there's a certain time, all right, specifically at time 2, the train is 400 miles north. All right, so we're going to look at time 2, all right, and we know that we're 400 miles north. I'm going to call this north for the variable, and I'm going to call this east down here, all right, because we have another train that's going this direction. Now, at time 2, all right, if we glance back to the last part of this question, all right, the last part says at time 2, we were 300 miles east. All right, so we know that we can put it over here, and we know underlying there's 400 and 300. All right, but again, we're not going to use those yet because we're really looking at a relationship in the rates in this one, and we're trying to find something about this distance here. All right, so when I look at my know, all right, I know that dn dt, all right, is given by the function, and it was labeled v sub b of t. All right, I know that dE dt, specifically when t is 2, which is the instant we're concerned with, all right, from the table is 100. All right, now we're concerned about time 2, so I'm going to actually go ahead on this first piece, and I'm going to say dn dt when t equals 2, and I'm going to calculate that in the equation. So I've got 2 squared, which is 4, 4 times negative 5, which is a negative 20. All right, and then I've got 6 times 2, which is, or 60 times 2, which is 120, so that's now positive 100, and then plus 25, so we have 125. All right, so just a little scratch work there off to the side. Don't need the graders to look at that, so I've got a 125 for that value. The find, all right, is going to be d dt, specifically when t equals 2. And then we go to our relationship, and the relationship in this one is Pythagorean in nature. So we have north squared plus east squared equals distance squared. If I take the derivative of this on both sides with respect to time, I get 2 north dn dt plus 2 east d east dt equals 2d dd dt. All right, now I'm going to plug in the values that I know from time 2. All right, at time 2, n equals 400, so I have 2 times 400. All right, dn dt at 2, which we found out was 125. All right, plus, then I have 2 times east. East we found out was 300. All right, times dE dt, which we knew from the given was 100. All right, that equals 2 times d. This is a Pythagorean triple, 3, 4, 5, so I can say 500 for d. All right, so I have 2 times 500 times d dt, specifically when t equals 2. All right, so from here, I've got 2 times 400 times 125 plus 2 times 300 times 100. All right, then I'm going to divide that entire side by the 2 times 500. Now, if I'm without a calculator, I'm honestly probably not going to go any further than this because this is totally sufficient for what the College Board is looking for. All right, so I could put this in context at this point, and I would say the distance between the 2 trains is changing at a rate of 2 times 400 times 125 plus 2 times 300 times 100 over 2 times 500. All right, and then I would look back to my units. So units, we were all the way up at the top, we were meters per minute. All right, so meters per minute at t equals 2. All right, and that would be our final answer, and that's a related rates problem. So that would be the conclusion for the last part here. If I check real quick just so that we have it there, that corresponds to 160 meters per minute if we go through that. So 160 meters per minute. But again, we don't actually have to calculate that unless we want to, because trailing calculations aren't considered. All right, I hope that helps. Thanks very much.